first question, we are told that the garden is in the shape of an isosceles triangle. And we're told that each of the congruent sides is 12. And we're given the area of the garden. And we need to find each of the three angles. So let's start off by finding the angle in between the two congruent sides. So I'm going to write down our area of a triangle formula with trig. Area equals 1/2 AB sine of angle C. And then I'm going to plug in what we already know. We have the area is 55 square yards. And we know that each of the two sides are 12 yards. And then we're looking for the angle in between, which is represented as C. So 12 times 12 is 144. Half of that is 72. So we have 55 equals to 72 sine of angle C. If you divide both sides by 72, we have 55 divided by 72 equals sine of angle C. And then to get the angle, all we have to do is take the inverse of that ratio to get angle C. When you type it into your calculator, remember to round according to the question. It does say the nearest tenth. So let's get what that is to the nearest tenth. Well, that was 55 or 72. So inverse sine of 55 over 72. And that's about 49.8. So that's approximately, for this angle, 49.8 degrees. Now, these two angles are going to be congruent because they're opposite from the congruent sides in the isosceles triangle. So if I go back to my calculator and I do 180 degrees, because all triangles make 180 degrees, minus the 49.8 that we got before, and then I divide that answer. I divide the 130.2 by 2. Oops. Let me clear that. And I get 65.1 degrees. So each of the other angles is about 65.1 degrees. So those are the three angle measurements, 49.8 and to 65.1 degrees. Question number 2, in triangle ABC, angle C is the 90-degree angle. If AC is 12 and BC is 16, which equation is not correct? Notice how in the first two answer choices, the focus angle is angle A. And then the last two answer choices, the focus angle is angle B. Remember, your labeling of the triangle does depend on the focus angle. So I'll start with the angle A's first. I'll see if any of them are not correct. And then I'll move on to the angle B. So first I'm going to start with the ones focusing on angle A. From angle A, we have opposite, we have adjacent, and we have hypotenuse. If we have 12 and 16, we can find what the hypotenuse is. Going to go over to my calculator, 144 plus 256. And I see that's 400. And then if you take the square root of 400, you get 20. So let's check out cosine of angle A. If I write on my paper, so Kachoa, cosine is A over H. So from angle A, we have A over H, 12 over 20. This one is correct. From angle A, tangent is opposite over adjacent, 16 over 12. That is correct. So now, to check out the other answer choices, I'm going to relabel my triangle because the other two answer choices focus on angle B. And from angle B, we're going to have to change some of the stuff here because from angle B, this is now opposite and this is now adjacent. Hypotenuse always stays the same. So sine of angle B is opposite over hypotenuse, 12 over 20, that's correct. Tangent opposite over adjacent would be 12 over 16, not 16 over 20. So answer choice number 4 is the answer choice that you are looking for. Over here in number 3, recognize that you have a big right triangle with an altitude creating two smaller right triangles. And if you think back to last semester, according to the right triangle altitude theorem, we have 3 similar triangles. The big right triangle is similar to the two smaller right triangles. And that's important here because when you have similar triangles, you have congruent angles and proportional sides. So if you have the same angle and you have sides that are in proportion, the trig ratio is going to be the same. So if I want to know if a trig ratio works, I have to see for all 3 of the similar triangles. So what I'm going to do is I'm going to redraw all 3 of the triangles so that they're facing the same direction. Always redraw your triangles so you can see what corresponds. For my big triangle, the right angle is at B. And then it doesn't matter where I put A and C right now. It will matter for the other triangles, but for my big one, doesn't matter. I'm going to base the other 2 off of my big one. Then I'll do the medium one. So I'm going to do this one next. In this triangle, the right angle is at D. And then I'm going to think about what this triangle shares with the big triangle. Angle C is shared between this triangle in blue and the whole big triangle ABC. So if it was over here in the big triangle, I have to put it in the same spot in this triangle because it's shared, reflexive property. So by process of elimination, that leaves B to be over here. And finally, we have our small triangle. The right angle is once again at D. And we have to think about what does this triangle share with the big triangle, and that's angle A. So if angle A is over here in the big triangle, it's got to be in the same spot in this one. And by process of elimination, that leaves B to be the last letter. And now I could see what matches up. So the reason why this is important is because I'm looking for the ratio that's equivalent to cosine of angle A. Angle A is over here in this triangle. It's over here in this triangle. But in this triangle, B corresponds to A in these 2 triangles. So even though this triangle doesn't have an A, the angle that's in the same spot corresponds and matches up. So they're congruent angles. And since there's proportional sides, there's going to be the same ratio. So we very well, when we're testing out cosine of angle A ratios, we also have to test out the cosine of angle B for this triangle because it's the corresponding congruent angle. So let's check it out. From this angle in each of the triangles, we have opposite, adjacent, and hypotenuse. Opposite, adjacent, and hypotenuse. Opposite, adjacent, and hypotenuse. So let's check it out. The cosine ratio for the black triangle would be adjacent over hypotenuse, AB over AC. The cosine ratio for this one over here in blue would be adjacent over hypotenuse, which is BD over BC. And finally, the cosine ratio for this one in red would be adjacent over hypotenuse, which is AD over AB. Now let's see which of these 3 ratios is in the answer choice. I don't see AB over AC, not the one we're looking for. I see BD over BC. So that one was tricky because if you didn't recognize that you have similar triangles and you didn't redraw the triangles, you might not have recognized that you actually have to check angle B in this triangle. And that's the one that actually ended up being the ratio you were looking for. The only correctly set up cosine ratio here in the answer choices. Okay, moving along. Chelsea is sitting 8 feet from the foot of a tree. So here is the tree. And here's Chelsea. Oh, let me make that a little bit lower. And Chelsea's 8 feet from the foot of the tree. From where she is sitting, the angle of elevation of her line of sight to the top of the tree is 36 degrees. If her line of sight starts 150 feet above the ground, how tall is the tree to the nearest foot? So actually, let me not label it that way. Give me 1 second. Now that I read the question. So Chelsea's line of sight starts 1.5 feet above the ground. So from her line of sight to the top of the tree, the angle of elevation is 36 degrees. And she is 8 feet from the tree. And we need to find how tall the entire tree is. So what we can find here is we can find using our right triangle, we could find this. But when we have this, that starts at Chelsea's line of sight. So we'll also need to factor in to the base of the tree, which is that 1.5 feet. So basically, after we find this purple side, we'll have to remember to add in that 1.5 feet so we can get the full length of the tree. Now that we have our diagram and our plan, let's do it. From this 36 degrees, we are finding opposite and we have adjacent. So tangent is our best bet here. Tangent of the 36-degree angle equals to what we're looking for over the adjacent side. Let's cross multiply. 8 tangent of 36 equals to x. Let me type that into my calculator, and that will represent this. And then I'll have to make sure to add the 1.5 feet in. So let me clear that out. Wait, I forgot what it was. 8 tangent 36. 8 tangent 36. And then we'll need to make sure to add 1.5 feet to our answer. And it says to round to the nearest foot. So that's about 7 feet. Notice how the answer choice before you add the 1.5 is also there. Before we added the 1.5, it would round up to 6. And notice how that's also a choice. Okay. In right triangle ABC, C is the 90-degree angle. Lowercase a means across from angle A, the side across from angle A. So lowercase a is right here. And we're told that that's 4. And sine of angle A is 1/2. Sine is O over H, and it's from angle A. So from angle A, opposite over hypotenuse is 1/2. But here we already have the opposite, and the opposite isn't 1. The opposite's 4. So wait, actually, instead of calling this x, I'll call this hypotenuse. So sine of angle A is 4 over H. But we know from here that the ratio should be equivalent to 1/2. So basically, you're thinking about what number can you plug in here that's going to give the same ratio as 1/2, because even though this number is not 1, it's 4, it should give the same ratio of 1/2 because we were told sine of A is 1/2. So the answer is answer choice 3, 8. 4 over 8 equals to 1/2. If I put an 8 here, then opposite over hypotenuse is 4 over 8, which reduces to 1/2. We have two similar triangles. Cosine of angle J is 3/5. Cosine from angle J is adjacent over hypotenuse. Determine and state the measurement of angle S to the nearest degree. Notice how angle J and angle C match up. That might have been hard to see because the triangles are not drawn oriented the same way. So remember when they have the letters of the triangles, it can help us to see what matches up because you might have thought that J and S were going to match up, but that's actually not true. J and C are going to match up on the two different triangles based on the orientation. So what I need to do is I need to find angle J. And once I have angle J, I can find angle C. And then once I have angle C here, I'll know what angle S is because angle C and angle S match up. So if I know what angle C is, I'll know what angle S is because similar triangles have congruent corresponding angles. So really, all I need to do here, because they already gave me cosine of angle J is 3/5. So I'm just going to do inverse cosine of 3/5 to get J. So I can get angle J. And let me do that. And I'm going to leave a couple of decimal places now. 53.13, I'll leave. So this angle is approximately 53.13. And so now, since all three angles of a triangle add to 180 degrees, and I know this angle and the 90-degree angle, I'm going to add 90. And then I'm going to subtract the result from 180. And it does say to round your final answer to the nearest degree, so that's about 37 degrees. And remember, angle C and angle S match up, so if that's 37, that's 37. So definitely use the letter names of the triangles to help you figure out what corresponds when you have similar triangles. Sometimes it can be deceiving. It's not what you think. So sine and cosine are cofunctions, and that means that they're equal when their angles add to 90 degrees, when their angles are complementary. So I want to make an equation that says if I take the angles of sine and cosine, and I add them and equal them to 90 degrees, then that's what I need in order for them to be equal. So that we have 7x plus 13 equals to 90. I'm not good at mental math, especially at this time of night. I'm not going to trust myself on that. 77. X equals to 11. We need the number of degrees in the smaller angle. It's probably going to be 11, but I don't want to just assume. So I'll plug in. Actually, no, that's the X value. So that's the trick. That's not an angle measurement. That's the X value. So I'm going to actually plug in. So 4 times 11 is 44 degrees. So that's one of the angle measurements. Then we have 3 times 11 plus 13. So that's 33 plus 13. So that's 46. And these two, let's just double check. Do these make 90? Yes, they do. So they are complementary. So that worked out. So the smaller angle is 44 degrees. Okay, we're talking about a parallelogram, and we have its area. Remember a parallelogram can be broken down into two triangles, and the lengths of its sides are 32 and 46. So we can find the angle in between using our area of a triangle formula since we have two triangles. But remember, since there's two triangles, we can half this area. So instead of using 594, I'm going to use 297. Our two sides next to each other are 46 and 32. And we're finding the angle in between. Sorry about that. So let me type this part in. 46 times 32 times 1/2. $736. To find the angle, we're going to do inverse. And let's see what that is. Make sure to type that in right. Yes. And I got approximately 23.8 degrees. And it does say to the nearest tenth of a degree. So I got approximately 23.8 degrees for this angle measurement of the parallelogram. And that is an acute angle. So that means this one would be the obtuse angle then. Because this one would be 180 minus 23.8. Over here, remember that we can only use trig for right triangles. So in order to find the angle, we have two right triangles. We have the whole big right triangle. I'll outline it. And then we have the small right triangle. So if we find the whole angle of the big right triangle, and we find the angle of the small right triangle, and we subtract them, we'll get theta, or the projection angle. So let's do it. I'm going to do small right triangle and big right triangle. So I'll start with the small right triangle, and I'll just keep it consistent with red, and then I'm not going to use yellow for the big one. I'll use a different one. So I'm going to use tangent of losing my mind, it's late. Tangent of y, that's what I call that angle, equals to opposite, 0.41 meters, over adjacent. We don't have the hypotenuse. So adjacent over here is 3.74 meters. And then to find the angle, I would take the inverse of the ratio, and that would give me the angle I need. And now for the big right triangle, once again, I'm going to use tangent. Okay, and 1.17 plus 0.41 1.58, because we need the whole side, over 3.74. So then to find the angle, we just need to take the inverse of the ratio. And then we could just do x minus y. Let me type this in, and I'm going to make sure of the order. I'm going to do x minus y, and then after I type it in, we'll round to the nearest tenth of a degree. So I'm going to keep flipping back and forth so I can see it because I'm going to forget. So tangent, I'm going to start with x, 1.58 over 3.74 minus inverse tangent, and the other one is 0.41. Oops. And that's about 16.7. Okay, over here, we need to find the distance the boat traveled from A to B. Once again, remember, we can only use trig for right triangles. So just like the previous example, we have two right triangles. We have the big right triangle, and we also have the small right triangle. So this time our plan is to find sides because we need the side AB. So we could find the whole side, the big side of the big right triangle. We can find the side of the small right triangle, and we could subtract to get AB. So once again, our plan is to do x minus y. The only difference is this time with sides instead of with angles. So just like before, I'm going to make a spot for big right triangle, and I'm going to make a spot for small right triangle. Now I did it in the right order for subtracting, so that's not going to be confusing. Tangent of the 15-degree angle equals to opposite over adjacent is what we're looking for. This over 1. Show out all your work because a lot of people will miss that you actually need to divide by tangent of 15 on both sides. Now for the small right triangle, tangent, and it says the angle of elevation at point B to the top of the waterfall is 23 degrees, equals to 188 over y. Same thing, show out your cross multiplication, because once again, a lot of people won't realize that you need to divide by tangent of 23. And now on my calculator, all I have to do is subtract x minus y, and then it does say to round my final answer to the nearest foot. So let me get my calculator. So the first one is 188 over tangent 15. Let me clear this out. 188 over tangent 15 minus the other one is 188 over tangent 23. And that's about 259 feet. Because it says round to the nearest foot. Let's check this one out over here. It's the last one. So what we need to find is the distance from the campsite to the tower. So we are looking for something different in this one. We're looking for that length. So that's the length of the hypotenuse. Once again, we need right triangles. So looking, same story as last time. We have two right triangles. We have the big right triangle in green. And that is actually the one that this is a side of, right? The big right triangle. Here, I'll outline it. And then we have the small right triangle. So these are the triangles that we want to use here to help us out. Now, I want to find this, but I'm looking at the big right triangle right now, And yeah, I got an angle in the big right triangle, but I don't know the side, and I don't know this full side. All I know is the piece that's the side of the yellow triangle. So if I was trying to make a cosine or sine ratio with the 55 degrees, cosine 55 equals to blank over blank. Two unknowns, not going to work. Sine of 55 equals to blank over blank. Two unknowns, not going to work. So what I need to do is I need to use my yellow triangle, which I do have an angle and a side, to get more information about my green triangle. So what I'm going to do is, since the yellow triangle and the green triangle have this side in common, I'm going to find this side. And then if I have this side, I should be able to use it with my big right triangle to find this. So for my small right triangle, I'm going to find opposite. So I'm finding opposite, and I have adjacent from the 72-degree angle. So I'm going to use tangent. So tangent of the 72-degree angle equals to x, that's what I'm finding, over 400. I'm going to cross multiply. And I have that this side over here is 400 tangent 72. And now I want to use that in order to find what I'm actually looking for, the hypotenuse of the big green right triangle. So I'll keep green. So I'm going to do big right triangle. So I'm going to call what we're looking for y, because I already used x over here. So in the big right triangle, we have the angle. We're looking for hypotenuse, and we just found opposite in part one, in what we just did. We just found opposite. So I'm going to use opposite because I have it, and I'm going to use hypotenuse because I'm finding it. So that's sine. And for opposite, I'm going to use the value we just found for opposite, 400 tangent of 72 over y. Cross multiply. And show out all your steps, because once again, a lot of people won't recognize that you have to divide. So now if I type this into my calculator, that represents the hypotenuse, right? Because sine is opposite over hypotenuse. So that represents the hypotenuse of the big green right triangle. So there I have it. And I can round according to the question to the nearest foot. So let me type this into my calculator, 400 tangent 72 over sine 55. And that's about 1,503 feet. And there we have it.